That's
or
good.
15.
Okay, so which one are we looking at? We are looking at 14.
Not necessarily 14, but 14 is kind of a part of it. But the main question that I have is about 15, and like I'm on 16 currently because I figure out how to
So
do
you
it. But I
want
was
to
just
work
wondering.
on the 14 and 15, or just, it doesn't matter
I
to
think it
me?
would be valuable if we went over it in class
Okay,
because I don't think we went over these type of questions.
very good. You'll see in a moment. We did, but it looked differently. Very good question. So let me copy 14 and then we'll move on to 15 and 16. How is that?
I think that
So
works.
first I look at 14. So we're asked to find dy over dx when y equals the square root of u and u equals x squared plus 7. Very good point. So let's take a look. One option will be, so I'm asked to find dy over dx. Okay, so I see that this is x squared plus 7. So I'm done. That's it. So I'm differentiating y with respect to x. So dy over dx or y prime, this is the square root of a function. 1 over 2, the square root of x squared plus 7 times 2x. So basically, this is just a substitution. It just tells me that y equals the square root of u, and I'm given u. All I have to do is just plug it in. That's it. There is nothing else to it. Is this okay?
Yeah.
Professor Lee,
Yes?
I have a general question.
Sure.
So there are problems that you can, when you're solving it, you can go on and multiply each other and all that. Where is the border? I mean, how much I have to do?
It's a very good question. So you're asking basically how far do I have to go with the simplifying it?
Yes, yes.
Perfect question. It depends on the problem and it depends on what we do with that step. If there is something that follows it, then we have to simplify it fully. But for example, in this situation, there is nothing I can do. This is carved in stone. This is it. There is nothing I can do. Could I have left it like this? I could have, but why not simplify if I can? So it's a very good question, but it depends on the problem. So we'll discuss every time we encounter something. So this was 14. So let's look at 15 now. Let's see what 15 is asking us to do. So they're asking in 15, they want dy over du. They want, yes, that's fine. Yes, I'm fine. Move away. Okay, du over dx and dy over dx. Okay, so they're giving us y equals u to 53. They're giving us u as 3x to the fourth plus 2x cubed. Perfect. Very good question. Okay. So dy over du, my props are ready here. So dy over du is just differentiating this. Differentiate y with respect to u. Y is a function of u. So then dy over du will be 53 u to the power 52. That's it. There's nothing else. So that is done. Now they want du with respect to x. No problem. Du with respect to dx, or u differentiated with respect to x, that will be 12 x to the third plus 6x squared. Done. Let's see what they want now. They want dy with respect to x. Here I have to be careful because one option is, like we just did, replace u in here. So then y is nothing else but 3x to the fourth plus 2x to the third to 53. Or you have another option, but this is the easiest. you just replace, I shouldn't say easiest, maybe the other one is easier sometimes. So all you have to do is find dy over dx. And you'll see what this is equal to, right? So now finally, y is a function of x. So I can differentiate. It's all a little puzzle, basically. dy with respect to x, I bring down the power, 53 times 3x to the fourth plus 2x cubed to 52 times the inner function prime, which is 12x to the third plus 6x squared. Another option is just replace this in here. That's exactly what it is, 53. When we replace u in here, and then times du over dx. Or you just say, I don't want to mess with that, just simply replace it. It's up to you. You have several options. How are we, sorry, let me stop for a second. How do we feel about these two? You just have to do exactly what they're asking. And if you don't have that, like here, I have dy with respect to u, y with respect to u, du with respect to x. I have it. But this one I don't. Oh, okay. How do I get from y to x? No problem. Simply replace u by 3x to the fourth plus 2x cubed and then differentiate. Okay, let's look at the next one. Okay, move away, I can see. Okay, so dy by dt for each pair of functions. Exactly the same idea. So do I continue? Is this okay, or do I need to continue? You tell me.
Are you asking me specifically?
No, anyone. If we understood this, then we can go and review. If we still need to work on problems like these, we can. It's up to you. Whatever you need help with.
Continue.
I'm sorry?
Can you continue?
Okay, so we have dy over dt. That's what we are asked to find. So y equals x squared minus 7x, and x equals t squared plus 8. So one option will be, since I want y and t, but I have x, all I have to do is replace it in here. And then differentiate, and that's it. So then y equals t squared plus 8 to the second power minus 7 times t squared plus 8.
Professor, we can't see your note. We see the,
Oh, of course you can see it. So we were asked to find dy over dt. So y equals x squared minus 7x. All I have to do is just replace. Another way would be to write dy over dt is nothing else but dy with respect to x multiplied by dx with respect to t. So one or the other, whichever works for you. This is the straightforward. This may be easier in a way, but this is the straightforward. So if I want to differentiate y with respect to t, but y is not a function of t, I can make it be a function of t because x is a function of t, then I have two steps. Or you just replace and differentiate. So dy with respect to x and times dx with respect to t. What is this? Exactly what we just discussed. So y is a function of x. So let me write it better like this. Y is a function of x that is a function of t. So y is a function of x, and x is a function of t. Y is a function of x, which is in turn a function of t. So then when we differentiate, this is the chain rule. Y prime of x of t times the inner function prime. This piece is this piece. This piece is this piece. Exactly what we discussed. This is a slightly more difficult notation, but it's exactly the same thing. Do we understand now better? Is this okay? Yes? No? Anyone?
I'm doing better with it.
Perfect. So let me finalize it. I don't want to leave it like this. So then dy over dt. You prefer to differentiate this, or you prefer to differentiate in 2 steps? You tell me and I will do exactly what you want me to do.
2 steps.
2 steps? Is that what you said?
Yeah.
Okay. So first, then I have to find dy over dx first. I'll come back to this. So let me write here one more time. Y equals x squared minus 7x. So then dy with respect to x is no problem, 2x minus 7. So this is this piece. Now we want to find dx over dt. I'm going to write x again. So dx over dt is 2t. So now I have to be careful because I'm asked to differentiate y with respect to t. So I have dy over dx, which is this, but I want to differentiate with respect to t. So instead of x, I have to replace what x equals to, t squared plus 8. So I cannot simply write 2x minus 7. I have to write 2. X is this, t squared plus 8 minus 7. So now this is dy over dx, dy over dx. 2 times the given x minus 7. And now I multiply by dx over dt, which is times 2t. The answer has to have only one variable, dy with respect to t, only one variable. I cannot plug in 2x in here, 2x minus 7. I have to replace x by t squared plus 8. And yes, I can simplify it a little bit. I'm putting this symbol here so that you know you can skip over this and continue here. So I will distribute 2t squared plus 16 minus 7 times 2t. And all I need to do here is put 2t in front and 2t squared plus 9. And I know everybody's going to ask, do I take it any further? No. It's factored. It's nice. That's all I need. Very good questions. Okay. Is there anything else from 1.7? So everything is what we covered last time. All you have to do is in one more step just to replace. Or use the 2-step solution. Is there anything else from here that we need to go back and look at? Anything else from 1.7? Anything else from 1.8 that you would like to go back to? Anyone?
I haven't finished them, so I wouldn't know.
So that's why I was hoping that everyone will, so we can solve anything here. Can you look now quickly and see maybe you need any help with anything? If not, I would like to start the review. And now I want to see if I still have the book anywhere. Do I still have the book anywhere? Yeah, it will allow me to open it. Okay, so do I need to review the piecewise defined functions? We have like 4 or 5 piecewise defined functions. Do we need to review piecewise defined functions again?